Welcome back to the second module of Unit 1, that is Mathematical Logic, and we'll continue with our connectives. Now, in the previous module, we have already talked about the three connectives, that is OR, and NOT, and we wrote down the truth tables for each of these connectives. In this module, now we talked about the two other connectives, conditional and biconditional. To start with conditional, we have already talked about what is a conditional connective. So in this case, there is a statement like if P then Q. So like if you look at this example, it reads as if the temperature exceeds 70 degrees Celsius, then the alarm rings. So we are saying that if the temperature exceeds 70 degrees Celsius, then the alarm rings. So if I look at this as statement P and this as the logical statement Q, then this is like if P then Q. This is how you'll write it. Now, one thing that we have to look at this is we are saying that if P happens, then Q happens. Only if P happens, then Q should happen. We are not talking about the other way around. Okay. The second example we may consider is this. If the institute does not commence by August, then I will cancel my course registration. So here also an example of compound statement when there is if and then that is involved, conditional connective that is involved. So your P is this is your P and this is your statement Q. So this is also in the form of P implies Q. It is saying that if the institute does not commence by August, then I will cancel my course registration. In fact, there is not that is involved here. So if I have to really write it in the notation form, I should be writing it as P dash, because there is not that is involved here. So your P is the institute does commence by August. So not P will be the institute does not commence by August. So if P then Q. So we want to write down the truth table for this. If P and Q are two statements, P implies Q, it is read as P if P then Q, or P implies Q. And P and Q is true if whenever P is true, then Q is true. Okay. So this is only talking about when P is true, Q is true. When P is false, it is not talking about what happens to Q. Okay. It only stresses on when P is true, then Q should be true. So let us write down the truth table for this. So for that, let me look at the statement. If the temperature exceeds 70 degrees Celsius, then the alarm rings. So let me consider this as P as we said, and this as Q. So I am making a statement saying that if the temperature exceeds 70 degrees Celsius, then the alarm rings. When will you say I am true? You will say that I am true whenever the temperature exceeds 70 degrees Celsius and the alarm rings. You will say that my statement is true. Okay. So if the temperature exceeds 70 degrees Celsius, that means P is true, and the alarm rings, that means Q is also true. You will say that my statement is true. When will you say that this statement is false? When the temperature exceeds 70 degrees Celsius and the alarm does not ring. The statement that I made was whenever the temperature exceeds 70 degrees Celsius, the alarm rings. So if the temperature exceeds 70 degrees Celsius and the alarm does not ring, you will say that I am false. My statement was false. Okay. Again, going back to what we said earlier, this statement only talks about the temperature when it exceeds 70 degrees Celsius, the alarm rings. So if the temperature does not exceed 70 degrees Celsius, whatever happens to Q, you will say that I am always true. because my statement was whenever temperature exceeds 70 degrees Celsius, then the alarm rings. If the temperature does not exceed 70 degrees Celsius, whatever happens to Q, I will always be true. So this is the truth table for the connective, that is conditional. So later in future lectures, we'll have to remember the truth values for conditional. For T and T, the truth value is T. For T and F, it is F. And for F, T and FF, it is T. This is the truth table for conditional. The other connective that we talked about is biconditional, if and only if. So suppose I have a statement, medicine will eat the fruit if and only if it is an apple. So there is this if and only if that is connective here. So there is one statement, that is P, that is medicine will eat the fruit, and the other statement is it is an apple. So this statement is like P if and only if Q. When will you say that this statement is true? When P happens, then Q happens, and whenever Q happens, then P happens. That means medicine will eat the fruit only if it is an apple, and only if it is an apple, then medicine will eat the fruit. That is how it works. Another example, a triangle is equilateral if and only if all the three angles are equal. Okay, this is one property that we learn in mathematics. If a triangle is equilateral if and only if all three angles are equal. So I have P here, I have Q here, and I have P if and only if Q. So whenever a triangle is equilateral, we know that all three angles are equal, and whenever all three angles are equal, we know that the triangle is equilateral. So if P and Q are two statements, P if and only if Q, it is denoted by this notation, okay, two-sided arrows. It means that if P happens, then Q happens, and when Q happens, then P happens. So if P is true, then Q is true. In that case, this will be true. If P is true and then Q is false, it will be false. If Q is false and if P is false and Q is true, it will be false. And both of them are false. That means if P is false, then Q is false. It will be true. If P happens, it is like you may look at it as the equality. If both the truth values are same, only then biconditional is true. If they are of opposite values, then the truth value is going to be false. Thank you.